Hey, let's take a look at a real-world application where you can see dilations happening right there in front of the eye of an artist. An artist is creating a large painting from a photograph by dividing the photograph into squares and dilating each square by a scale factor of 3. So we're going to make it 3 times as big. If the photograph is 8 inches by 12 inches, what is the perimeter of the painting? So we've got this great photograph of an eagle, and what the artist is going to do is cut it up into little square pieces. This is how you can sort of enlarge things, because then all the artist has to do is take that one little piece and look at it, and now imagine magnifying it for each length of 3 times the size, and then sort of painting that little piece and then putting it all together, and then it's 3 times as big. And the question is, what's the perimeter of the new image? So let's think about this. Let me just draw. This picture is curly. That's because it's a photograph. You know, photographs sometimes curly, unless there's someone that's bald. Then that's curly up. It's a joke. All right, here we go. So we have, let's say, 8 by 12. And now we're going to enlarge that, so it's going to be a scale factor of 3. This might not be drawn to scale, but what does that mean? It means that this is going to be 8 times 3, and this is going to be 12 times 3. And so that means that this length here, this is a rectangle, is going to be 24, and this length here is going to be 36. And so what is the perimeter? Well, the perimeter is going to be 36 plus 36, which is 72, plus 24 plus 24, which is 48. And so I see 120. What are my units? They're in inches. So I see 120 inches. That's the perimeter of the painting, which if you compute the perimeter of the original photograph, you'll see that if you take that perimeter and multiply it by 3, we're going to actually get the perimeter of this. So it all corresponds. Dilation.